recorded. All right, so what we've looked at is the Hardy-Weinberg principle, and we're doing probably number 2 that talks about, and I'm going to shrink this one time, that an allele W for white wool is dominant over an allele small w for black wool. In a sample of 900 sheep, 891 are white and 9 are black. Calculate the allelic frequencies within the population, assuming the population is meaning Hardy-Weinberg equilibrium. All right, so we had to take 9 divided by 900. And no problem, Ingrid. 9 divided by 900 gave me 0.01. So that equals Q squared. All right, the second thing that I'm going to have to do is, what did I say? We have to take the square root of it. Number 2 was also take the square root. So I got to hit the square root button, and I find that it's 0.1. Okay, so that's actually 10%. If we know anything, we'd put another 0 behind there, and that'd be 10% of the population. So Q equals 0.1. So the next step is, and I'm just doing this over and over again, and I've shown you the steps, okay, is I have to take $1 minus 10 cents. So could we figure out, if I clear it, that's 90 cents. 1 minus, and I'm just doing this for you, 0.1 equals 0.9. Of course, that gave us P. Step number 3, very easy. I got to take that and square it. So I just hit that button and I get 0.81, which makes sense. 9 times 9 is 81. All right, so now I have all of them so far. And in the chat box, I'm going to show you and write it down. And hopefully, at least you can see it. So we determined that Q, when we took the square root of it, equaled, okay, 0.1. And P equaled 0.9. Okay, I put that in the chat box. We take P squared, which was our next thing, P squared equals 0.81. And I screwed that up in the chat, but 0.81. So that's what P squared is. Same step, we just did the fourth step. And we have one more step to do. 2, and let's see, I bet you I can test Joaquin with this one. 2 times 9 times 1. Is it going to be 0.18? Yeah. So look, we're going to have 2, and I'm putting this in the chat box, times, it was actually right, 0.9, right, times 0.1. And so wouldn't that equal 0.1? Wouldn't that equal 0.18? All right. And I bet you, just to check to make sure you do understand this, I'm going to do 2 times 0.1 times 0.9. And you see where that's going, 0.18. All right, so it should have been a little bit easier. That's all the question is. And we're going to do this every time for every one of these problems. All right, let's go to the next one. Number 3, I thought, no, I didn't do that one. All right, there's Fernando. Let's bring him in. Okay, 2 other people are waiting. Wow, we got a crowd. Admit all. All right, everybody should be in. Hopefully, I'm going to shrink this down. Hopefully, Fernando gets in. If not, I will get back to him. All right, I'm going to shrink this down. Hopefully, you can still see the screen. All right, number 3, in a population that is Hardy-Weinberg equilibrium, the frequency of the recessive homozygous genotype is a certain trait is 0.09. So what are they saying? The frequency. Okay, so this is Q. This isn't, okay, wait. The homozygous genotype is certain. Calculate the percentages of the homozygous to the dominant allele if Q equals 0.9, right, that's Q, okay, and P equals that. So we want to know how many homozygous dominant are. That means P squared, okay? Now, didn't I do this already almost for you? I left it in there. Q equals 0.09, I'm showing you that. So $1 minus 0.09, wouldn't that give me P9 0.91? So we have one step to do to get the percentage of individuals that are homozygous. Anybody tell me what that is? How do I get homozygous dominant individuals? Anybody at all? Is it Q squared or P squared or 2PQ? It's one of those three. Do you remember from our video? Anybody at all? Anybody? All right, Joaquin took a shot at it. Let's see. I'm going to look at his thing. And he said, no, damn it. Okay, we were close though. All right. It's P squared, isn't it? Look. You guys are driving me nuts on this one. All right, I'm going to go back over to here. And what does it say? This is what it says. P squared is the frequency of the homozygous dominant. Q squared, and this is on all the documents. It's on the document we're doing. It's on, it's on my Zoom thing. And you just saw that, right? Joaquin. So, you just watched this. So again, that's available for you. So the only thing I need to do is square P. So I'm going to find my freaking calculator again, whatever the hell that is. And I'm going to move my screen back up so we can see everything. 0.91 times 0.91, or just hit 0.9. Oh, crud. Go back. 0.91, and I'm going to square it. And I get 0.83. All right, we're going to round it up. Now, if you put 0.82 on a test, is it close? I'm going to be looking for, is it close? I'm not your damn math teacher. So the answer is 0.83. Okay. Everyone in the meeting. Okay. So what do we try to find? P squared equaled 0.83. Okay. Everybody was here. That's what it's asking for. Calculate the percentage of individuals that are homozygous for the dominant allele. We just did it. Number 4, I did in class. Okay. Let's go to number 5. All right, the allele T for the ability to taste a particular chemical is dominant over the allele small t. The inability to taste, 400 university students were surveyed, 64 were found to be non-tasters. Oh, wow, this is a tough problem. 400 minus 64, that's our first thing, right? Because we got to know, all right, no, actually, 64 out of 400 are our Q squared. Those are the ones that can't taste. The ability to taste is dominant over the ability to not taste. 64 couldn't taste it. Read the problem. So what we'll do is we'll start with exactly what we should have from the very beginning again. We're going to take 64 and we're going to divide that by 400 to find out what Q squared is, because that's the amount of people. Just like I gave you the example in the classroom, okay? In the classroom that we had 5 kids with blue eyes. All right, hold on, everybody. And if Joaquin does not, if Joaquin does not know, expect us to know. I'm going to tell you, the person who told you, I don't try not to use too many names, but Fernando, as long as they don't use your last name, because I'm recording this and that way I can use it in the classroom and put it in there and nobody will even know it's there. And I have all the answers in there because I think this is a tougher concept to get. Some of you, and Joaquin would admit this, he's not the smartest kid in every one of his classes, and sometimes he gets it wrong. And you're right. Sometimes somebody else gets it right. And sometimes you're just afraid to answer. Don't be afraid to answer. Okay, I'm asking Joaquin because I go, it's probably 90% he'll get it right. But in class, that's why I don't really call on too many students to answer questions. This is going to be a freaking easy problem, isn't it? So we know if Q squared, and I'm going to do this, okay, another words of wisdom. You have to ask for help. So Q squared equals 0.16. That means that we have 64 non-tasters, basically. Let's do the same thing we're going to do on every problem, okay? Aren't we going to take the square root of that? So I take the square root of it. Oh, it's 4. Because 0.4 times 0.4 equals 0.16. You should almost be able to do that yourself. And on the test, I gave you easy answers. So Q equals 0.4, 0.4. It's an easy problem. That's our next thing. Step 1, step 2, we just did it. Okay, the next thing is I have to take $1 minus 0.4. Fernando, what's $1 minus 40 cents? I know you know it, Fernando. You have $1 and I take away 40 cents. How much do you have? Yes, of course, that's right, Joaquin, but I knew you'd answer it. So he thinks that like some of these other kids couldn't do this. All right, obviously, if I take $1 minus 0.4, it's 60 cents. That's the way I look at it, Joaquin. So maybe that helps you as well. Okay, so that you don't always need a calculator. I like mental math. Like you have to be able to calculate things at the store before they rip you off. Like if your taxes are around 8%, just round it up to 10% and go, okay, I should pay about this, a little less than this. And then at least you know. Otherwise, they rip you off. I'm telling you that. All right, so 0.6 is P. Cliff, text me. I don't know if he did or not. All right, let's go back to this. This question is for number 5, isn't it? Yeah, I believe so. Let's look. Sorry. Yeah, it's number 5. Very good, Abigail. All right, so I have what? Now I have $1. Wait, I said that. We just did that. So P equals 0.6. Now, anybody, can they tell me what P squared would be? Just take a random guess. What would P squared be? Anybody in the chat? Oh, at least one of you got it right. One of you is passing math. Of course it's 0.36. What is 6 times 6? 0.36. What's the square root of that? Oh, I did it twice. Let's go square root. Square root again. There it is. Square it. 6 times 6. Unsquare it. What does 6 times 6 make? All right, start getting used to this. All right. Now, we did that. So we just put P squared. We have one more step. Okay, so we have one more step to do, and that's 2 times P times Q. And I bet you Jordan just got in here, and we can ask him the question. Because you say, I always ask Joaquin. Well, Jordan's here. Jordan can answer. Actually, all of you can. There's just not one of you that I think cannot answer this question. And I'm glad you're here, Jordan. All right. So if we have 0.6 and we have 0.4 and we have 2. Let's see if we can get this one right. Let's see who the first one is. Maybe I'll give you candy. Doubt it, but maybe. What is 6 times 4? Anybody? All right. Yes. Maya, awesome. Yeah. You guys are good.
24,
yes.
24.
24. Yes. Okay, here's the big question. What's 24 times 2?
48.
See, Fernando, why'd you say everybody else knows? The answer is 0.48. Look, 0.6 times 0.4 times 2 equals. All right. That is 2PQ. We just did all of them right there. So let's go back to their answers. And it says, what did it ask? Just calculate 2PQ. That's all it wanted, 48%, even though we did all of them. Okay. And I think it's important I went through all the steps because you'll know how to do each one. All right. I did this one in class, and this one I actually have on my other video. So what else one have I not done? Oh, I said this one, and this is one of the hardest ones. All right. In corn kernels, color is dominated by the dominant allele white. White is dominant to what? By a recessive. Okay, for the white color and by a recessive allele. All right. Yellow. Yeah, so this is yellow because it says it here. And we should probably have yellow in there. Should say yellow. So we know that one's white and one's yellow. Otherwise it was confusing. It says down here. A random sample of 100 kernels has a population that revealed that 9 are yellow and 91 are white. Now, do you notice how they're using 109? Because it's easy. All right. So we're going to start with the very beginning again. So if I need to find out what the ones that are the fewest, just like I said in class, the 5 kids who had blue eyes versus most of the kids who have brown eyes, because we know brown is dominant. In this case, we know yellow is recessive, and that's the one we always start with. And since we know we're looking at individuals, not just a yellow W, so 2 Ws, that's 9 out of 100. Can anybody guess what that number is? If you have 9 cents out of 100, what is that going to be? Let's see if we can do this without the calculator. Anybody? 9 cents out of 100.
91?
Joaquin is incorrect. Okay, Ingrid, how can it be
What'd you say?
10 cents? 9 cents. How do we freaking write 9 cents? 9 out of 100 is 9 cents. How do we write 9 cents? You get 9 cents change. What does it look like?
0.09?
Put it in the chat box so I can see it, see what you're talking about. I can try. Okay. Yes, Fernando, that is absolutely correct. Okay. And Fernando came up with it. But why? It's why it kind of surprises me. That is Q squared for everybody. Isn't it 0.09? Joaquin, you gave me 91 cents. Not a problem. Right. It happens when we rush. But 9 cents out of $1 is easy. Okay, that's Q squared. We just did that one. Now, and this could be Joaquin or anybody. What number times what number is going to give me 9?
Three
Right?
times 3?
See, Fernando, you're on it. Okay. So wouldn't it be 0.3 times 0.3 would give me 0.09? Okay, I'll show you. You're right. 0.3 times 0.3 equals, oh my God, 0.09. Okay, so we really didn't need the calculator. That's what I'm trying to tell you. All right, so what did we just find out? That everyone in the meeting, let's do this again. So we had Q squared. Okay, remember Q squared equaled 0.09, and we figured this out. See, Fernando got it first. So Q has to equal, and we're just doing the same steps we always did, 0.3. Now, without a calculator, what's $1 minus 30 cents? 0.30. Anybody? Yes, sir, it is. Anybody else? Very good, Maya. Perfect. All right, so now we found that. Remember, $1 minus Q equals P. So P is 0.7. Okay, P equals 0.7. And I'm putting that in there. Jordan, I can try to scan back up where I can kind of go over some of them again for the kids who are late, because there was a few of you. All right. Now, without a freaking calculator, what? Yes, this is the last problem, Abigail. Yes, I got it right here. Hopefully you can see it. All right. All right, Abigail, what is 7 times 7? Or anybody?
49.
Right. 49.
49.
Good. All right, so I'm going to go 49. And I bet you I'm right. Whoops. Yeah, no problem. Sometimes, like I said, we're rushing, and there's only one of you that missed it. All right, so if I have 0.7 times 0.7 equals 0.49. Okay. Now, don't you wish your math teacher was just like me teaching math? Wouldn't it be easier? You're like, yeah, he explains things. It's actually easier. He actually shows me. And then he tests me on it. Then he gets the light bulb. Look, math is just like when I see that you get the light bulb, you're like, oh crap. Okay, then I can move on to something else. But unless you get the light bulb, all you have is rain pouring on your head and the ceiling. All right, so what we've done is we've calculated Q squared, and we've gotten Q, and we got P squared, and we got P. So the only thing we need next is this, the heterozygous ones. So here's another one we can do without a calculator. We're going to take 2 times 7 times 3. So what's 7 times 3? Okay, and what's that times 2? Okay, see, now that's why I want you to do mental math like that. Perfect. Try to think of things scaled down. 0.42. So the answer is going to be 0.42. So in order to do this, and I'll just square this again. Whoops, let's clear it. So I'm just showing you that you were absolutely correct. So we got 0.3, we got 0.3 squared. We had started with 0.09, then we got 0.3, then we got $1 minus 0.3, and we got 0.7, then we just got 7 squared. So 0.7 times 0.3, I'm sure it's 0.21, okay, times 2 equals 0.42. So you did that all without having to have a calculator, okay? So, and that's kind of the idea of almost everything in math, is you can't depend on these things. All right, so I've done number 7. I did number 6 in class, and it's also in my video, okay? This one we just did a little while ago. Now, if you want to find Q squared, take 64 divided by 400, and I'm not sure if kids were in here, so I will give you Q squared, and you're just going to do the same damn thing I did every time. So I'm going to take 64 divided by 400, because that's how many people it was out of. Just like my example of 5. So it's 0.16. All right. And so, Jordan, were you here for this problem?
Turn your mic on.
Nah.
Okay, good. All right. So this is number, Jordan, you're going to solve this whole thing for us. This is number 5. All right. So Jordan, what number times what number will give me 16? And you can say it. You don't even have to like type it in.
8.
Oh, come on. Is 8 times 8 16? What number?
Oh, I'm sorry.
No.
I'm sorry.
What number
4.
times itself, right? Okay.
4,
So,
Borden, 4.
all right, I got you. I got you. Yeah, thank you. Thank you. And yes, he got it eventually. So it's 4, right? So this is 0.4, okay, would be the square root of this. So if I hit the square root of that, whoops, it was square. Square root of that, I get 0.4. What's $1 minus 4? 0.4, 40 cents. Jordan? Anybody? We've already done this.
Can you re-say that?
Yeah, I sure can. What is $1 minus 40 cents?
60 cents.
So it's going to have 0.6 is P. Now, I want to get P squared. And I'm just going through the 4 steps over and over and over again. Okay, so what is 6 times 6? It takes you a while, you guys. You got to know your times tables. Yeah, it is.
What was that?
What is 6 times 6?
36.
Yes, thank you. So
36.
we get 0.36, okay, as Q squared, as P squared. And then what is 6 times 4 times 2? And you said 6 times 4 is 24 times 2 is 48. We did this problem. Okay. That's what that is. So in other words, Jordan, this is much easier. I did everything except for number 1 tonight. And this is, you want to see how easy number 1 is, since you guys are here? All right. If you have 2 alleles and they're giving you this and they're giving you this, and they want the heterozygous, don't I take 0.19 times 0.81 times 2 to get that? Isn't that P? Isn't that Q already? That's how I get that. 2 times 0.19 times 0.81. Done. This says homozygous recessive. What do we know about that? That means Q squared, the small one. Okay, it's going to be close to 0.64. The reason why I know that is it's 8 times 8. So it's going to be 0.81 squared. if I do it, it's got to be close to 0.64. So I can even take a hypothetical guess and go 0.881, right? And I can square it. And it's going to be close to 64 because 8 times 8 is 64. Okay, so I know my number's right. Okay, so now I've done almost all these problems. All right, so your freaking quiz. And then I'm out of here because I said I'm not taking too long tonight. All right, that's how I knew all this. I put it on there like that. Okay, so that when I keep going over it, do this, do this, do this. Where do you see that? Right here in my video that I made. Okay, so like if you're at home, like right now, right there, Q squared, do that, do that. Those are all the steps you're doing. Okay, and just if you repeat it over and over, and I did this one, like, hey, yeah, the 38, this is number 6 or something, or 4 inside the thing we just did. All right, so I will do one more thing for you. On your test, I will help you a little. And actually, what you probably do, maybe we should just do that, because you're going to help yourselves. Then I didn't really help you, did I? I'll ask you what some of the, how you set up the problem. So once you get Q squared, you should be able to do it. Okay, here's the Hardy-Weinberg quiz. And this is probably what Joaquin was doing. Okay, and it should be easier than another problem because I probably made that. I know because I made this. It's as easy as I can get. All right. Oh my God. Yeah, this is how freaking easy I've made this. I put the steps right here. It's like I actually told kids this is how you do it. That's how you do it. So if I have 1,024 people with 2 big G's, 512 with small in that, and 64 with that, I have to add up all those to find out and then take 64 and divide it by that. Oh God, all right, so good, Clifford. Okay, I'm proud of you. Okay, if you're like, this is low-key easy, then good, you're actually learning something, and that's what I'm proud of you. I mean, and again, I think it's also having somebody that's going to be able to communicate, like, so that you can actually do this correctly. All right, so this one is probably your hardest problem on here. So we'll kind of, I'm going to set it up together. So if I have 1,024, Joaquin, is this the one you were doing? Plus 512, because I have to total up the total number of people. Was this the one? Yeah. Okay, I'm confused on what you were doing. Plus 64. And you're confused right now. I don't know why. All right. I have 1,600 people. Oh my God, Mr. Borden actually made it really easy. 1,600. Okay. We know that that's going to be an easier thing. So watch. There's 1,600 total total what? Lizards. Okay, I'm like people. No, green scales. Okay. All right. So I know that, right? So I have to take 64 divided by the total number. Remember, I had to do that in class as well. Okay. So number 1, and I'm going to give you Q squared, and that's it. I'm going to take clear. I'm going to take 64 and I'm going to divide that by, oh crud, what did I just say? 1,600, right? 1,600, yeah. And watch. Oh my God, Q squared is 0.04. Do you think we can do it now? I hope so. What times what makes 4? $1 minus that number. Okay, look, you're going to do the same thing over. Look, I gave you Q squared. Okay, so number 1, I just did that. I'm not typing it in here because it's a quiz. All right, that might have been one of your hardest problems. Okay, but look at this one. How are we going to find this? And so, do you see how I made it an easy number, even though it doesn't look like an easy number? But when you got to it and you go, oh, well, Q squared is 0.04. Well, I know what times what makes 4. So I know what $1 minus that number is. And I know what 2 times this is. I don't need a calculator to do this. Number 2, if you have 1,092, and you can kind of predict this in 108, how many am I going to have? Now watch, watch what mental math is. So I just take 1,092 and I'm gonna add $100 to it. So I'm gonna have 1,192, and then I'm gonna add 8 to that. Oh, 1,200. Now I'm gonna take 108 divided by my 1,200. And I'm gonna show you what that is. And I'm sure it's probably an easy number. Okay, so I'm gonna take 108 divided by 1,200. Maybe it's not an easy number because I remember the quiz, I gave you a couple that were not easy. Oh my God, that is an easy number. 0.09 is Q squared. Are you starting to get this, kids? I mean, really, is this easier than you probably thought? And there's a lot of teachers that don't want to teach it because I don't think they know how to teach it. And that's one of the most important things that, I think at freshmen and some of you that are a little bit older. So, I'm not dumbing things down. It's just, okay, it may take me a little longer to teach you. Okay. There's 100 kids in the class and 84 did well. So 16 blew it. So 16 of that's going to be 0.16. The answers are going to be the same as one of the other ones at the top. In fact, many of these answers are the same. Wait, what number one again? Well, number one, remember what we say was, didn't I say it was 0.09 or 0.04? This was 0.04. Q squared equals, I'll do this to everybody, damn it. Make me do this. Q squared equals 0.04 for number one. Damn it, where's my Q? Gotta have my Q in there. All right. So that was for number one. For number two, Q squared equaled 0.03. Now wait, was it 0.09? That's what it was. All right. So I gave you the first two and I showed you, you add up all the things. And I even told this to kids. Divide the recessive trait number by the total of all individuals. That equals your Q squared. I just showed you that. We added them all up and we divided it by how many had the recessive trait. 64 had that trait. That's how we figured it out. All right, now. All right. Do most of you get this now? Okay, I'm hoping so. Was it as hard as you thought? Somewhat. Okay. All right. Where am I losing you? Where am I losing you? That's all I'm asking is where the heck am I losing you? Okay. Let's go back to this thing in the video. Where am I losing you? At the beginning. All right. Why at the beginning? Okay. So if I have 14,500 people and there's 38% that have it, can I tell you how many that is? Yeah, I'm going to have to use a calculator for this one. So I'd have to use 14,500 times 0.38. And I'll tell you how many people actually have that trait. I just did it at the very beginning. So you have to add up all the people. Okay. Again, I gave you the example at the very beginning of class and said, we have 5 people that have blue eyes. We have 25, okay, total kids. So we have to take 5 divided by 25, and I'm sure I'll get 5. Okay, and that's how you did it. So 5 have it, 20 don't. Yes, you just divide. And I put that in there. Okay, Q squared to Q. You take the square root. I wrote it, take the square root. I put it on the test as well. 1 minus P, subtract this. And I put this on the test right there. I couldn't get more specific with this. Bold. We'll make it in bold for kids. No. Look. I'm going to go now. I really. All right. Yeah. You have a good rest of your evening too. And I told kids that I'm getting off in 4 minutes anyways. Okay. Good. All right. Yeah. No problem. And you're welcome. All right. So watch. That's how I did this. I took 1,024. Now look, you guys said you could see my calculator on here. Okay. Damn it. Okay, there it is. Can you see the calculator? Ingrid, you can? Tell me you can.
Yes, I can see it.
Okay, good. So I'm going to take 1,024, just like I did before. 1024. And there's 512 also that have the middle gene. Okay, the heterozygous gene. Oh, that's not going to work for me. Okay, 1024. Wait, damn it. Now I got to start over. You screwed me. It's all your fault, Ingrid. That's how I blame my wife and everything. 1024 plus 512, 1512 plus the 64. That's how I'm going to do it. I first have to add them together. Okay. But how do I get Q's too? So there's 1,600 total people, people, freaking lizards, coloration of lizards. Okay. Okay, some of them have blue, some of them have green scales, some of them have like something in between. Okay. Now, there's only 64 that have this one, and this is what I'm looking for. One that has two small letters. That is Q squared. So in order to get Q squared, all I had to do was take 64 divided by 1,600. Okay. So I'm going to go like this. 64 divided by 1,600 equals, and I told you it was 0.04. So Ingrid, you're going to help me with this.
Yes.
What number times what number makes 4? Times itself, meaning.
What?
What number times what number makes 4? Times.
2 times 2.
Thank you. So 0.2 times 0.2. Okay, if I take the square root of 0.04, I'm going to get 0.2. Correct? You just told me this.
Yes.
Okay, I just did it. I just hit the button. What's $1 minus 20 cents?
80 cents.
Thank you. That's P. What is 8 times 8?
64.
That 0.64 is P squared. How many homozygous? That's 1024 of them. Now, to find out about the heterozygous ones, heterozygous right here, what is 2 times 8?
What?
What is 2 times 8?
16.
Times 2. Screwed you up on that one.
32.
Very good. All right, you just got your calculator out. All right, could you do that a different way? What's 2 times 2? 4. What's 4 times 8? 32. All right, so any of them, like remember it's 2 times 0.2 times 0.8. So I just took 8 times 2 times 2, and you had 16 times 2. You can do it other ways. All right, it doesn't have to be one way. You get the same answer either way. All right, so I gave you, you just solved number 1. You got all the answers for number 1. All right, I'm stopping this now.